day, grade 10 learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. We are going to have our lesson today, grade 10s, about what? The surface area of prisms and cylinders. Okay, we're going to have the lesson about the surface area of prisms and cylinders. Okay, right. Now you are going to enjoy the lesson, grade 10s. Let's make sure that we are ready, and we are going to be doing a lot of work like we usually do, isn't it? Okay, right. Let's be ready for our lesson. You can write today's date and everything, the topic, and we start. Right, so at the end of the lesson, you should be able to solve problems involving the surface area of prisms. Okay, we're going to do that in this lesson. Right, and then we have done the area and volume for the other shapes. And then now I want us to do this baseline activity. Tick the objects or 3D shapes that are prisms. I want you to tick objects that are prisms here, if there are any. If there's no prism, don't tick anything. But if there is a prism or many prisms, you can tick the boxes there. Right, don't worry about what you observe about the prisms. We're going to answer that once you have done the ticking. Let me give you just 1 minute to do the ticking. Tick the objects that are prisms. Let's do that for 1 minute. Okay, well done, grade 10s. The first object number 1, what is it? Is it a prism or not? It is a prism. We've ticked that already. It's a triangular prism. Triangular prism. We're going to explain why it is called what? A triangular prism. So that one is ticked for us. What about object number 2? Is it a prism or not? It is a prism. It is a prism. That's a rectangular prism. That's a rectangular prism. Right. Object number 3. Object number 3 is not a prism. It is not a prism. So that's a sphere. Right. Like the earth is a sphere, is spherical. A soccer ball is spherical. So those are spheres. An orange is spherical. Those are spheres. Right. That's a sphere. Right, and then shape number 4, object number 4, what is it? Is it a prism or not? It is not a prism. This one is what? A pyramid. It can be, that could be a square pyramid. The base is square, so it's a square pyramid. Okay, that's a pyramid there. It's not a prism. You see that? So it's not like all 3D objects are prisms. They are prisms and things which are not prisms. Okay, you have to know the difference there. What about cylinder? Cylinder is interesting. Cylinder is very, very interesting. So this one is not a prism, but it behaves like a prism in some of the aspects we are going to discuss in today's lesson. Okay, right. So that's why we have said we're going to look at the surface area of prisms and cylinders. Okay, so a cylinder is not a prism. I'll explain why. And then after that, we'll see that in some of the aspects we're going to talk about today, especially the surface area, the cylinder behaves like what? Like a prism. Okay, right. Now, I want to give you maybe 2 minutes for you to discuss why is shape 1 or object 1 and 2 prisms, why list object 3, 4, and 5 are not prisms? Can you discuss that for 2 minutes? And then when you come back, we'll do our discussions together. Let's do that for 2 minutes. Four, five, six. So it is a hexagon. You see that? So you see a hexagon this side. I will turn this shape around and then let's turn it around. What do you see this side? We are seeing the same shape, which is the hexagon. You see that? So there is a polygon this side and a polygon this side. Same polygons. Hexagon this side, hexagon this side. And then these two shapes are called bases. These are the bases and they are parallel to each other like this. You see, the hexagon this side, the hexagon this side, they are parallel to each other. Okay, right. And then we take this one here. This is a square pyramid. What do you see this side? We see a square. When I turn it around like this, we don't see a square. We just see the tip here. You see that? Okay. And then even this side, if I turn it like this, we see a rectangle. We can turn it around again. We're seeing what? We're seeing a, oh, no, we're not seeing a rectangle, a triangle, sorry. We're seeing a triangle. And then we turn it around, we're seeing a triangle. But what is the difference between this shape, the one that I discussed previously? We said these polygons must be parallel to each other, isn't it? But if you check these two triangles, they are not parallel to each other. You see, they are meeting there. They are not parallel to each other. They are not parallel to each other. This one, we said the hexagons are what? Are parallel to each other. So this is a prism. This is not a prism. Let's talk about a cylinder. Yes, the bases are parallel to each other. You see the circle. You see the circle this side. They are parallel to each other, isn't it? Just like the prisms. But a circle is not a polygon. Do you see that? Okay, it does not have vertices. It does not have the corners. The vertices are the corners. So that's why I said the cylinder will behave like a prism, but it is not a prism because of such things. There we don't have vertices, there we don't have corners. You see that? Okay, but it has what? Parallel bases. Right, the other thing, the prism, we said that, let me use another one, a rectangular prism. Right, you see a rectangle this side, you see a rectangle this side. And then what joins these two rectangles? What joins these two rectangles? We have a rectangle, a rectangle, a rectangle, a rectangle. We call these ones lateral faces. We have the bases. This is the base. This is the base. They are the same. And then we have lateral faces, which are called what? Which are rectangles in this case. Even the hexagonal prism, if you check, the lateral faces are what? They are rectangles. We have a hexagon this side, a hexagon this side. Then the lateral faces are what? Are the are the rectangles. Are the rectangles. So that's what prisms are. So I hope you have managed to understand the difference between prisms and other 3D objects. Let's continue. We're going to discuss what I've been showing you here, but now I'm going to be showing you on the what? On the screen, okay? Right. So what did we say? We said that prisms, I hope you are listening. Now, don't write a lot of things. Right. Prisms have a pair of congruent. When you're saying congruent, it means what? Same size, same shape. That's congruent. Right. Prisms have a pair of congruent faces, which we call bases, that are parallel to each other. Like this is the base. This side, let me show you. This is the base. This is another base. So these two bases are parallel to each other. Then they are joined by the rectangles. You see that? Okay. Now that is our hexagonal prism. You see that? Okay. And then even our triangular prism, we have two triangles, two triangular bases, and then they're joined by the lateral faces, which are what? Which are rectangles. Let me just show you. Okay, this is the base, this is another one, then we join them like that, you see? And then we have rectangles joining those bases. You see that? So a prism, if you check one end, you see a polygon, you turn it around, you'll see at the same polygon. That's a prism. Okay, this is a prism. You see this shape, you turn it around, you see the same shape. That's the prism. Okay, so it maintains its shape throughout its length. Okay, right. And then the other thing, what did we say? We said that the bases are perpendicular to the rectangular lateral faces. Okay, perpendicular to, they form a 90-degree angle. See, this is the lateral face, then they form a 90-degree angle like that. So they are perpendicular to the lateral faces, right? And then the base of a right prism is a polygon. We talked about that. We even said why a cylinder is not what? Is not a prism because of that. And then I want us to do this one in 2 minutes. What shape is this? Now you should be able to name this. This is a triangular prism because you can see a triangle this side and a triangle on the other side. And then they're joined, these two bases are joined by rectangles. Do you see that? Now, how many faces is a triangular prism composed of? You answer that. And then after that, you name the 2D shapes that make up what? This triangular prism. Let's do that in 2 minutes. Right, welcome back, returns. How many faces did you see there? There are 5 of them. There are 5 of them. Right, the question, the second one says, name the 2D shapes. So even if you said triangles and rectangles, it's still okay, okay? But there I gave you the number of rectangles actually. I said 3 rectangles and 2 triangles. But even if you said triangles and rectangles, you have answered the question, okay? Right, so there are 5 shapes there. 2 triangles and 3 rectangles. Do you see that? Okay, let me just do this. Let me say we have A, B, C, D, E, F. You see? So there's triangle. Try to follow my vertices. Triangle ABF. Do you see that triangle ABF? And then there's triangle DCE. You see triangle DCE? And then there's rectangle ABCD. Do you see triangle ABCD? You're just checking there on the screen. Don't write anything. ABCD. And then there's another rectangle ADEF. This is F. Do you see rectangle ADEF? That's another rectangle. And then the rectangle at the bottom there, BCEF. You see, there are 3 rectangles and 2 triangles. You see that 3D shapes are made up of 2D shapes. You see that? Yes, 3D shapes are made up of what? 2D shapes. Right. So it's very, very easy to find the areas of what? Of a 3D shape. You just find the area of the 2D shapes and add them. That's what we're going to do. So it is very, very important for you to understand that the 3D shapes are composed or made up of what? Of 2D shapes. So we know how to find the areas of rectangles. We know how to find the areas of triangles. So we find those areas and then we just add them. We get the surface area of the whole shape. You see that? Okay, right. So let's move on. This is the net. I want us to talk about the net. What is the net? What is it? Can you try to link this net to the diagram there? What happens? When we open a what? A prism, like in this case, when you open this triangular prism, we're going to have our triangles, okay? So this can be triangle A, B, F. You see that? That will be triangle A, B, F. This will be triangle D, C, E. You see that? This triangle D, C, E. We have opened up the prism. And then what are we going to have? How did you open it? Just there like that. So this can be rectangle. And then here you can have your A, D, E, F. That's the rectangle. And then we have this rectangle at the center, which is B, C, E, F. You see that? Try to link the net and the actual diagram there. Right. This is rectangle BCEF. And then the last rectangle will be BC and then DA like that. See that? So you should be able to link the net with the actual object. That's the net. When you open up the prism, you get what we call the net. Right. So given a hexagonal prism, we said that, now it's just repetition. We said we have the bases, like this will be the base, and then this will be the base. These are the parallel faces. They are parallel to each other. And then we have what we call the lateral faces. We have talked about this, the lateral faces. So this is like the face here, which is what? Which is a rectangle. That is the lateral face. And then we have what? We have the height of the prism. I want us to talk about the height of the prism. What is it? This is the height of the prism. So now, this is the distance between the bases. You see, there's a base here and the base here. This gap between the bases, that's the height of the prism. Because most of the times we talk about the height when the dimension is like going up like this. Your prism can be put like this. Okay, some books, they'll say length, okay, of the prism, but just know that the distance between these parallel bases, this gap, That's the height of the prism, okay, or the length of the prism. But the length sometimes will confuse us, because if you take this prism like this, we have length and breadth, isn't it? Okay, we have length and breadth. So if we refer to this one as the length again, it may confuse you. Okay, so we say length, breadth, and then the height of the prism, which is between the two bases. That's the height of the prism. Are we fine with that? Okay, I really hope you have understood the prisms. I want us now to start calculating what? The surface areas of what? Of prisms. Okay, we're going to start doing that now. But before we do that, I want us to try this. I want you to try even without the dimensions, but just the net. We're going to discuss later, but I want you to draw the net, just the net of this rectangular prism. Try. I know sometimes drawing is a problem. Try to draw the net of this rectangular prism in 3 minutes, and then after that we're going to discuss. Right, welcome back, rectangles. Right, how many rectangles did you get? Let's check that first before we look at the shapes. I know the shapes will be very, very funny, but it's fine. Okay. Right now, let's check the numbers. Right, this is a rectangular prism. How many faces do we have? 1, 2, isn't it? And then 3, the front, 4, the back, then 5 at the top, then 6 at the bottom. So now there are 6 rectangles. So if you have 6 rectangles, very good. Very good. Now let's look at how remember the net may be different in shape. Do you know that? It may be different. We can represent it differently. So Sometimes you have to check. Don't say because yours does not look like mine, then it's wrong. No, it may be correct. Okay, but now I cannot draw all the options now. Okay, I'll just show you one, but check if yours also is 6, and then also you may also compare and discuss with your colleagues there. Okay, right, this is my net. It looks like this. You see that? Okay, so this is the net here. Right, how many rectangles made up the rectangular prism? We have said that there are 6 of them. 6 rectangles. Right, 6 rectangles there. And then indicate the dimensions on the net. I want us to look at these rectangles now, and then we're going to what? We're going to talk about those dimensions. Okay, right now, so this is from there up to there. That is actually the height of the prism. You see that? Because it is between the 2 parallel bases. That is the height of the prism. That's 30 there. And then we have, what will be this one? The 25. That's the width of the prism. Do we have any other side which is 25? Okay, right. I will put a star to those sides that have also, they are also 25. This one will be 25 also. You see that? Any other side that is going to be 25? Or maybe let's also put our height and see. Right, 15, where is 15? Oh, this is still 25, and then 15 is here. Do you think we have another side which is 15 on the net? 15, let's use a tick. This is going to be 15, isn't it? Okay, when you fold, it becomes our height. This is going to be 15. Okay. Any other 15 here? This is going to be 15 also. You see that? According to my net, remember I said your net may be different from mine. Right, 25, this is going to be 25. I'm putting a star for 25. This is going to be 25 here. This is going to be 25. And then these ones are 30s. Now, what do I use for 30? A dot. These are 30s. You see that? These are 30s. You see that? Okay. So we just wanted to indicate the dimensions on the net. Right. Now, and then, now we have this shape. Which shape is this one? It should be the one at the front and the one at the back. So these are the two shapes, the one at the front, and then we go to this one. You see that? It represents the one at the back. You see that? Okay, these are the two rectangles, the one at the front and the one at the back. Okay, and then we come to this one. Which one is this? Which ones are these ones? Is the one at the top, the bottom, or the one on the left and the one on the right? It should be the top and the bottom. So we have the top one, which is like this, and then this one should be the one at the what? At the bottom. You see that? Okay. So you have two of each. Top, bottom, front, back, left, right. Now let's go to the left, right. We have this one here. This is the left, which is this part here. You see that? And then we have the right there. You see that? So each they go in pairs. Top, bottom, right, left, front, back. So there are 6 of them, isn't it? There are 6 of them. Right. And then using the dimensions of each rectangle. Now, how many rectangles we have talked about? We say there are 6 of them, but remember they go in pairs. Okay, I've named them here. A goes with A, B goes with B, and then C goes with this C. So now we're going to do it pair by pair, isn't it? Now I want you to find the area of the rectangles which we named A. The 2 of them, we named them A. Find the area of these 2 rectangles. Let's do that in 2 minutes. What's the area of a rectangle? How do we find the area of a rectangle? Is length times breadth, or length times width. Let's do that in 2 minutes. The area of the rectangles we named A. Let's do it. Right, welcome back, rectangles. Did you manage to find the area of our rectangles? So now this will be the front and the back, which is 30 by 15. So it means the length of this rectangle is 30 centimeters. The width is going to be 15 centimeters. Means this distance here is 15, same as that. So this is the area of the rectangle we're talking about. Okay. So it's this one at the front and the one at the back. So we're going to say 30 times 15 centimeters. Okay, centimeters. Right, and then times 2, because there are two rectangles, the front one and the back one, so it's times 2. So I've done this. So someone could have said 30 times 15, then get the answer and then say times 2 is still okay. So if you have 900 square centimeters, that's correct. Okay, right, let me show you the rest of the rectangles right now. And then we have another pair B, which means it's the top one and the bottom one. So it's this one. What are the dimensions of this orange one? It's going to be 25 by 30 centimeters. So it's 25 times 30 centimeters. But because there are two of them, the one at the top and the one at the bottom, we're going to say 2 times 25 times 30. So 2 times 25 times 30, which is 1,500. Okay? Right, we've done the A, the B's, and then let's go to the C's. Which ones are the C's? Okay, this one on the right and the one on the left. What are the dimensions of this one? The C is 15 centimeters by 25. Oh, my pen is not clear here. Let me change the color. Let me use the black color. Right, so this is the right. So it's going to be 15, and then here is 25 centimeters. So it's going to be 15 times 25. And then if you say 15 times 25, what do you get? You get the answer and then say times 2, because there's one on the right and the one on the left. And then we get this answer here, which is 750 square centimeters. We're saying times 2 because there are two of them, times 2 because there are two of them, times 2 because there are two of them. And then what do we do after that? We just add the areas of these two D-shapes, and then we get the total surface area of the prism. Do you see it is easy to calculate the area of a prism? Okay, but now there is a formula that you may get. I'm going to show you the formula to do this once. You can say that the total surface area is 2 times length times height. Like the first one, this one, the A's, we said 30 times 15. 15 is the height. Do you see that? So it's the length times the height. And then we went to 2 times length times breadth, which was the top one and the bottom one. 30 is the length, 25 is the breadth. So 2 times length times breadth. That's the formula there. And then plus. Take note, there are pluses here. We're adding these areas. We're adding them. And then 2 times breadth times height, which is the C's that we did there. The breadth is 25. The height is 15. Do you see that? So this is the formula that you can use to find the surface area of a rectangular prism. Not all prisms, rectangular prism. But you have seen that when you're finding the area of a prism, we're actually finding the areas of the two D shapes that makes that make that prism. Okay, right. I want to show you another method, which is very, very easy. You can use it. It's going to be faster. Right, but I want us to discuss first before you try, isn't it? Right, there's something we can do. So what we can do, we can find the area of what? Of the bases. You know what we're saying, what we're talking about when you talk about the bases. We said this space and this space are the bases. So we find the area of this base, we find the area of this base, and then we add them, or just say 2 times because they're the same. For prisms, they are always the same. So we can find the area of this base here that I'm highlighting there, and the area of that base there. Okay, and then we add them, or we say 2 times. The area of this base is going to be 15 times 25 in this case. And then you can say 2 times 15 times 25 because they are 2. Okay, and then I want you to observe something. This perimeter of the base, or let me start by saying The lateral faces, let's remove these bases. Just concentrate on the lateral faces. What shape do they form? If we open them up, what shape do they form? They form a rectangle, a big one, a big rectangle like this. Do you see the net? Right. Let me go back a bit. Right. I am removing these bases. I am remaining with the lateral faces. So now we're removing the bases, we're removing the lateral faces, we remain with a big rectangle which is made up of those lateral faces. You see that? And the distance or the perimeter of the base, this distance around the base there, is equivalent, it is equal to the length of this big rectangle that we have formed. It is equal to this length. Do you believe that? Like here, from there to there, we have 25. So this can be 25. And then from there to there, we have 15. This is 15. And then from there to there is 25. This is 25. And then from there to there, that is 15. We have 15. You see that? So we add all those. 25 plus 15 plus 25 plus 15, which is the perimeter of what? Of the base. So to find the surface area of this part, we can just say the perimeter of the base times the height of the prism. Then we have found the area of the lateral faces. The perimeter of the base times the height of the prism, we have found the area of the lateral faces. Then we just add the areas of our bases. Remember, we started by calculating what? The area of the bases. Okay? So let me say it again. What do? We find the area of the bases, okay? And then we find the area of the lateral faces by saying perimeter of the base times height of the prism. Then we add those two things. Do you think you can try that? Let's see. We're going to use the same shape, but now using this method, okay? Let's try. I want us to start by finding the area of the two bases. Let's do that. Find the area of the two bases. The bases there will be A, B, C, D, and E, H, G, F. Let's find the area of those two bases. Let's try for 1 minute. Right. Welcome back, returns. Let's mark our work. Let's mark our work. So now it is going to be 2 times 15 times 25 because this is 25 centimeters. So it's going to be 15 times 25 times 2 because there are two bases. Now let's find the area of the lateral faces. What did I say? How do we find the area of the lateral faces? We say the perimeter of the base times the height of the prism. What is the height of the prism in this case? Is it going to be 30 centimeters? Yes, it is 30 centimeters because that's the distance between the parallel bases. That's the distance between the bases. So the height of the prism there is 30 centimeters. So let's calculate our area of the lateral faces, the 4 lateral faces. Okay, these ones that go around like this. Okay, let's find that by using the perimeter of the base and the height of the prism. Let's try to do that in 2 minutes. Right, welcome back, grade 10s. Right, now how do you find the area of the base? It's the distance around, sorry, not area, perimeter. The distance around the shape. It is very easy to find the perimeter. Do you remember that? Because you don't even need a formula. Just know that perimeter is distance around the shape. Okay, distance around the shape. You get me, say 25 plus 15 plus 25 plus 15. You're going to get the same answer. But this one is a rectangle, so we can say 2 times 25 plus 15. Okay, because there are two of them. There's 25 here and 15, this one, and then there's another 15 and 25, this one. So you can say 15 plus 25 times 2. Then you get the perimeter, which is 80 centimeters. Now, this perimeter times the height of the prism will give us the surface area of the lateral faces. So we just say 80 times 30, which is 2,400 square centimeters. And then we add this and we add this. We are going to get the total surface area of the prism, this rectangular prism in this case. Okay, so let's add those two. Do you see that we are getting the same answer? We are getting the same answer. So I've shown you two methods. I want us to try to use what we have learned to do an activity. Okay, and then after that, I think we'll be done. So I want us to try. But before we do that, let's look at this. This is the formula that you can have. Let me give you 1 minute to write your short notes. I didn't give you minutes to write notes in the previous ones, but it's fine. Now, can you just write short notes here? You say the 2 times the area of the base plus perimeter of the base times height of the prism. That's how you find it. Let me write the other one for you so that you can write the two formulae. Total surface area. We said is going to be 2 times, and then the front one is going to be length times height, then plus the top and the bottom is going to be 2 times length times breadth, plus 2 times breadth times height. Okay, let me give you 1 minute to write these two formulae. We're going to use them in the next but the next one is going to be a triangular prism, so we're not going to necessarily use this, but just write it so that you have your notes for 1 minute. Welcome back, grade 10s. Right, can you try our question? Let's do it. You can do this. Now, let's find the area given the triangular prism ABC, which is an isosceles triangle. Okay, we know an isosceles triangle, right? You have got two sides that are equal, so it means them AC and AB are equal, isn't it? Right, calculate the total surface area of the triangular prism by calculating the area of 2D shapes in the prism. 2D shapes in the prism, sorry. Right, let's do that in 3 minutes. I want you to find the areas of the 2D shapes that make up this prism, and then you add together, and then after 3 minutes we are going to mark our work. Please don't wait for me to give you the solutions. Let's try. Even if you don't finish after 3 minutes, is fine. We just continue. and then I'll give you the solutions. Okay, right, let's try that for 3 minutes. Right, welcome back, greetings. I really hope you managed to do something. Even if you did not finish, it's okay. We tried, isn't it? Okay, right. We are going to discuss A, and then I'm going to show you B, and then for that, I give you the homework, then we'll be done, isn't it? Right. Now, so we're finding the areas of what of the 2D shapes. We can see that we have 2 triangles there, and 2 triangles and 3 rectangles. So now, this is the area of the 2 triangles. Area of a triangle is half times base times height. Our base here, BC, is 60 centimeters. And then our height, remember the height, we use the perpendicular height, not the slant height, okay? So our height there is 40, that's the perpendicular height. It must be perpendicular to the base. And then we're getting 1,200 for the 2 triangles. So it means if you calculate for one triangle, you get 600, and then you say 600 times 2, or 600 plus 600, you'll get 1,200, okay? Right. We are done with the area of what? Of the triangles. And then the rectangles, are they the same? The 3 of them? They are not the same. It's only the 2 that are the same. Try a rectangle ACED and rectangle ABFD. They are the ones which are the same, isn't it? Otherwise, triangle BCEF, the one at the bottom is different from the others. So you have to be careful when you're dealing with triangles. All the rectangles may be different. If it's a scalene triangle that forms your bases, all the rectangles are going to be different. If it's an isosceles triangle that forms the bases, 2 rectangles are going to be the same. And then if it's an equilateral triangle, then all the rectangles are going to be the same. Okay, so be careful when you're dealing with what? The triangular prism. So you see we have this and this because we have two rectangles that are the same, which is the 80 by 50. Even the one at the back there is still going to be 80 by 50. You see that? And the one at the bottom is the one which is 180 times 60. You see that? And then we're adding this. Take note of that. We're not multiplying them. The area of a rectangle plus the area of another rectangle plus the area of the third rectangle. And then we what? We get our area, which is 12,800. And then we add these two. We add these two. We're getting our 14,000 square centimeters. 14,000 square centimeters. Right. And then what did B say? Let's go back a bit. Right, I said calculate the total surface area of the triangular prism by calculating the area of the two bases and that of the lateral faces. Do you remember that? So we say the area of the two bases, we already done that, isn't it? We say the area of the triangles here, they're going to give us what? We have done that. It was 1,200, isn't it? The area of the two triangles. And then the lateral faces, it will be the perimeter of the base times the height of the prism. So the perimeter of the base will be this, and then times the height of the prism. Okay? So let's do that together. Right, so it's going to be the area of the two bases here, which is this part. And then the perimeter of the base is going to be 60 plus 50 plus 50. You see that? That's the perimeter of the base. And then times the height of the prism, which is times 80. You see that? And then we're getting what? Our 14,000 square centimeters. Still, we're getting the same answer. Do you see that? Yes. I really hope you have managed to understand the total surface area of what? Of prisms. Okay, right? I'm going to give you homework. I want you to try this homework. If you check, we didn't do the circle. The circle is in the what? In the homework. Calculate the surface area of the triangular prism by calculating the area of the two of each two bases and that of the lateral faces. Okay, right? Now check now the face. The perimeter of a circle is a special name. It is called what? Circumference. Here is the formula for finding the circumference. Okay, and then we have the height of the prism there, and then we can find what? We can find the total surface area of this circle. Okay, this is your homework. Let's try to do it. Please copy. If you can copy the question, the top part, and try to just draw at the diagram and the formulae there. That will assist you a lot. Don't copy everything. Let me give you 2 minutes to do that. The top part, this, and then this part, the diagram, just a neat sketch, and then the formula there. If you can see the formula, maybe it's not clear, but I hope you can see the formula there. And then if it is not there, you can even check your textbooks. The formula will be there. And try to find the total surface area of what? Of a cylinder. Even if you can look at the textbook, you should be able to interpret and understand how they do the calculations for the surface area of a cylinder, isn't it? Okay, let's do that in 2 minutes, then we summarize our lesson. Right, welcome back, grade 10s. Now, we say that the surface area of a right prism is the sum of the 2D shapes that make up the surface of the prism. Okay, we did that. We found the areas of the rectangles and triangles, right? And then the total surface area, you can say 2 times the area of the bases plus the perimeter of the base times the height of the prism. You can do that to find the surface area of a prism. Remember, we know what a prism is. Surface area is expressed in square units. Please don't forget that. Square centimeters, square millimeters, square meters, and so forth. All right. Now, thank you very much, grade 10s. We're going to meet in our next lesson and enjoy the rest of your day. Goodbye.